Today's book is a prerequisite text for anyone thinking about platforms, systems, open architecture, or deep structure of disruption. On the Innovation Show, we have spent years interviewing people on how industries break apart and reform, from Christensen to Osterwalder, from McGrath to von Hippel. Today's book is the Rosetta Stone that connects all of them. Once you know what a modular operator is and how it generates real options, you can reread so many other thinkers at a deeper level. 3 lenses for us to apply today. 1, for founders or operators. Modularity is the engineering precondition for ecosystem strategy. You cannot platform an interdependent product. 2, investors. The book formalizes why modular industries spawn many small, valuable firms, while integral industries spawn few large ones. It will help you know what to look for and what questions to ask. And for incumbents, once a competitor splits your architecture, you face an irreversible value migration. The IBM System 360 story is the cautionary tale that we might share today. And that indeed is the book's tragic irony. The act of modularizing your product is the very act of inviting your future competitors into existence. We know well the innovator's dilemma. This is the mechanic that underpins that concept, and it is even more important in this age of AI. It's an immense honor to host both authors in an Innovation Show exclusive of their, in my humble opinion, massively underrated, underappreciated book, probably because it was too early, and now it is certainly of its time. First up, welcome back to the show, friend of the show, and a guy I call a friend, Kim Clark. You're very welcome back.
Good to be here. Thank you.
Great to have you back always, Kim. I always enjoy our chats. And then a lady I have just met, and I hope to have back many more times on the show if I pass my audition today. Carliss Baldwin, welcome to the show.
Thank you so much, Aidan. It's a great honor to be here and wonderful to see Kim.
The honor is all mine. I thought we'd start because there's an entire vocabulary for the book. It took me a while to learn it. I had written it down in one column when I was reading the book, and we don't have time to share all that vocabulary, but I thought we'd start with the key term itself. Carliss, maybe ladies first, and then Kim can build on it. But the term itself, what is a design rule?
A design rule is a formal constraint made explicit that allows people who are not directly involved in the creation of the design to create complementary designs that are compatible. So they don't have to be there at the creation. They are not integrated into the original design process. But with the design rules in place, you can build a platform system. Design rules are, in fact, the platform, a platform system that can be extensible and creates many, many, many options to develop in different ways.
Kim, maybe you'll come in and give us an example of a design rule at play.
Clothes are a great example of, you can buy shoes and pants, shirts, jackets, dresses from completely different firms that have no idea the other people are working on stuff. And it all fits together when you do it because there are a set of design rules. And if you start looking for them, they turn out to be everywhere. They are a really important feature of modern life. Without them, we would not have what we think of as, everyday things. You think of, you just walk into your kitchen sometime and look around you, and you see modularity in action. The frying pans are not 18 inches wide. They're just not. The burners on your stove, they're all kind of about the same size, and they all plug into the wall in kind of the same way, and they use electricity the same way, and they plug into the gas. And everybody can work together. You look at, you just walk around your house and there's modularities everywhere because we have a set of design rules that allow completely independent firms who were not involved in designing the rules to function and operate. Where it becomes really powerful is in a technology where modularity unlocks incredible value. And that's what we discovered really when we dug in deeply into the IBM story and the computer industry, because inherently in that technology, once you got away from analog devices and got to digital, you were moving into a technology that it's so incredibly powerful that it's unfolded the way it has over the last, almost now 60 years because of modularity. I mean, we love to say that modularity was the underpinning of Moore's law. I mean, you don't get Moore's law without modularity, and you don't get everything we see around us that's electronic and digital. It all depends on modularity.
Maybe we'll build one term in there because you say in the book, design is the process of inventing objects or things, like you said, that perform specific functions. But these options, the products of human intelligence and effort, are then called artifacts. And artifact is a key term to understand modularity as well. Maybe we'll explain that.
Oh, you have to go to Carliss to do that because she's the wizard behind turning anything into an artifact. And
No. Well, technologies have sort of a fundamental nature. And before digital technology, almost all advanced technology was various forms of, flow processes. I mean, the idea was you made things be bigger, and they went faster. And as you sought this and speed, companies also get bigger and faster. And that's a fundamental flow process. So it's A is connected to B is connected to C. And to a first approximation, everything happens in order. And there's a set of prescriptions for making those technologies more efficient. It's you standardize the steps, you connect them, you make each step the same length, and you keep looking for the bottlenecks. That was production as I was taught when I was an MBA student. Kim skipped the MBA. He went straight to the PhD. But there's a whole set of technologies, from railroads to steel to automobiles to airplanes. They all fundamentally work the same way. And they do not really reward modularity, although sometimes you can modularize a flow process and run things in parallel. But to first approximation, modularity is not a goal. So digital technology comes along, and it has a very, very interesting structure in that half of it is hardware, and that's circuits. And circuits basically are not too different from flow processes. It's the electrons are flowing through the circuit. But the other half is software. And they're strict complementary. Without one, the other is worthless. So you have this immediate dilemma, because software then, this pre-Claude, software then was a writing process, a handwriting process. And once it was written, you didn't want to rewrite it because that was very, very arduous. So here you are, a manager, and you've got one thing that has Moore's law going for it, where you just want to turn over the designs as fast as you can and get faster and faster and faster. As the interface of that and the instructions is this enormous barrier where in order to run a different, faster set of circuits, you have to rewrite the instructions, scratch, by hand. And this was something that IBM was all geared up to come out with model after model after model, and they wanted a whole, originally they just wanted to do upgrades. They didn't think of a whole product line. But here they were stuck with this software problem. And their customers did not want to rewrite their hard-won software to buy the next bigger, better machine. So this was like a tremendous problem for sales. It was just going to stop it in its tracks. Nobody wanted to do upgrades. And so IBM's chief executive gathered together 12 or 14 engineers with different but complementary skills. I used to say they put them in a motel in Connecticut. Turns out it wasn't Connecticut, it was a nearby village in Connecticut. They did this in late November, and they said, you can't come out until you solve this problem. I mean, Christmas is coming, right? So everybody understood the problem, and they solved it by creating design rules, which said that if you follow these rules that are at the top of the heap, then your software be performed on the next largest machine and the next largest. So you never have to rewrite the software. It just gets run on a bigger machine. And that bigger machine can also run more software, bigger software. And so it ended up being quite a brilliant suggestion. And they understood, the guys who were part of its group, they said, it just made sense. By the end of they gave the report, I think, on December 27th. But I think they got to go home for Christmas. They said, we became more and more convinced that it would work. And indeed it did. And that was the first real conscious exercise of a modular platform strategy. We actually have lots of platforms. The high street of a village is a platform. It's got all these stores. They're all different from each other. And they benefit from the presence of others. But nobody thought of that as a strategy. That was just a street. But with IBM and the 360, they needed something formal and transferable and a set of principles. So it was, I claim, it is the one of organization design that was not just a natural extension of what was happening, but was invented. It was an invention. So flow processes, they're just, they go back to the pyramids. We've always had sort of these people agree that it's a platform and they use its flexibility. Job shops are just the way people get work done if they don't have a lot of work. If it's a small enterprise and they need flexibility and variability. A line staff organization like an army or a government or a corporation, that's just sort of, you start with job shops and then you link them together with staff. Or you have flow processes and you link them together with staff. But modularity, you have to actually set out to make it modular by creating the design rules and having the modules obey.
So Aidan, let me go back to the idea of an artifact. Then I'm going to use the one that's used in the book. See this? It's a mug. And it has certain elements to it. You can see them now. And this is something that we believed in very strongly. You can see it all through the book and all through Carliss's subsequent work, which is really pays dividends to know the details of the design, to actually understand in pretty significant detail what is involved in creating a design, right? So, you've got a handle, you've got a receptacle, you've got a lid. But if you've read it, I mean, there's a lot that goes into like, well, how does the lid fit on this thing? How does it, how do you kind of make sure that it's right? And you can see immediately as you design this thing that there are all sorts of decisions you have to make about the structure of this quote artifact, which is essentially a collection of little design choices that you make in order to create something that someone can use and use effectively. So if you think about that idea and go back to the computers before the IBM 360, they had the same exact issue. But the only thing they knew and understood how to do was to create the hardware, which required a lot of design choices, because you had to create interfaces just like you do here. Like, what's the interface between this and the customer? Well, right now it's a straw. Okay. But you have other kinds. You could make this like a little flippy thing that you flip up and, so you had choices about how to design the hardware of the computer. And then you had to figure out how to make it do things. Well, the problem they had was that the only way they knew how to make the computer actually work was to create a set of instructions for the computer. And in the early days, they didn't know how to write software. In fact, the idea of software wasn't even around. The only thing they knew how to do was to write instructions in the hardware. And then it's actually called the instruction set, and it gets hard coded in circuits. They knew how to do that. And then they knew how to tell the customer how to access those instructions. But it was all, in a sense, it was just like this artifact. You designed it, all fit together. You figured out how to make it work. It's fantastic. Okay. The problem was that they wanted to create new hardware. And so that all unfolded. And the artifact itself, the hardware in the computer, fundamentally didn't change all that much. It just got faster and bigger. So you could do more with it. So that meant you could make the little circuits smaller, essentially. So the electrons didn't have to travel as far. And essentially that's what's been going on it's Moore's law. So that artifact, the fundamental issue was that it was as if in order to have a mug, you now had to create some kind of instructions that the customer had to give the mug before it would work. And that's the next thing that happened was that they figured out that, all these different things that customers really like, for example, they liked to be able to print out what they were working on to create a document. So printers became a thing. And, we can actually now, because guys invented another piece of hardware, and I was in the plant in San Jose and I saw these things, these enormous discs. They weren't like little ones. These were great, big, huge discs. And they figured out how to make a device where you could send a digital signal to the device and it would encode it in the hardware that is in the disk. And they could put them in this big stack and you could sell a disk drive and you could store enormous amounts of information. And the customers thought it was fantastic, right? So those devices existed before the 360, but they were all linked to that construction set. And so it's not only the software that had to change. All of a sudden, the customer had to buy new printers and new disk drives. It was a mess. And They didn't want to do it. And so they figured out. But as you mentioned earlier, once IBM split architecture up and they figured out how to do it, by the way, doing it was not easy. We can talk about it like, oh, they figured out modularity, so they just designed it, made it modular. Well, that was like super difficult, really hard to do. But they figured out how to do it, and they pulled the instruction set out of the hardware, and they had to figure out how do you make the machine talk to the software. And so they figured out how to do it. Right. So they split it. And now you could upgrade the machine and you didn't have to change software. And they figured out, well, if you have design rules for that, now you can have design rule for the printers, design rules for the disk drives. You don't have to buy new disk drives. By the way, we have new disk drives if you want them, but you don't have to buy them because we can upgrade your computer and give you a whole new thing and it's faster and so forth. Well, that was the beginning of the fundamental change in the computer industry, right? It was, you could see it in action. You could watch it happen because 12 engineers that worked in San Jose, where they made all their disk drives, walked out the door and they formed new companies, started with one new company to build disk drives. And that spawned this enormous disk drive industry. And they became really much, much faster than IBM and much better at building drives. Even though IBM had the world's best scientists working on it, the guys, it turned out that once you figured out, oh, it's like how to encode in the drive, you can make them smaller and faster and so forth. Anyway, and that's why the disk drive industry, and the same thing happened with printers and every other peripheral that IBM had. But IBM figured out, oh, this is actually really good for us. So they didn't try to kill these people because what they just realized is, oh, this means we can create an IBM compatible, essentially, no, we had those language in those sense, ecosystem, because the 360 became a platform. And somebody once said, after the 360, this is hard to imagine today, but the announcement of the 360 was like an enormous event. It was covered by all the newspapers. It was covered by TV. It's this enormous event in New York. And the 360 got introduced because people realized, oh, this is completely different. A few years later, not very many years, people stopped talking about IBM as a competitor. And they just said, IBM is the environment. And if you look at the graphs we'd created, Carliss did our magic, created all these beautiful graphs about value and stuff. I think, if I remember right, IBM had something like 90% of all the value in the computer industry was in IBM. And that was with all this disk drive and printers and all this stuff that was around. Yeah, there you go. And it was like unbelievable, it was incredibly valuable. So that was the peak. You saw there the peak. It's good.
There's so much here. I mentioned it's the Rosetta Stone. And what I mean there is when you read it, it took me a while now, I have to say, and I see the depth of research that you've done. And Carliss, now you've gone and released Design Rules 2, which is just a massive body of work. It's a lifetime of work. But when you start to get it, you start to go, well, now I understand actually the source of where Clay Christensen, may rest in peace, got the idea of the innovator's dilemma, because it's the same thing. It's like, by doing this is a dilemma. I have to do this because I can't continue to grow. I can't continue to work this way. I need to start to let go of parts of it. I need to create an ecosystem like IBM did. But if I do that, I can create competitors. And the competitors can actually be better at some parts of the thing that I used to do. And it's a huge dilemma. And as you told me before, Kim, that the IBM, they did try to sue some of the guys who worked out, right, who knew the design rules, because the design rules were almost like the blueprint. Maybe we'll talk about that, because I think for people, when they listen to this or they hear or they see the book, they'll be afraid of it, like I was. but when you do start to understand some of these rules, you just have these moments. And one of those moments for me was understanding, and I'm pretty sure Steve Jobs read your book and went, we're going to do that. We're going to understand the design rules, except we're going to orchestrate the entire ecosystem.
Yeah, you look at that diagram that you've got on the screen, right? And peak years are late 60s up to about 1970. And it just was the case that some people figured out, we can create computers that are not as big, not as functional, but they really provide a different service to people. And that's where, Digital Equipment Corporation came from, right about this time. And they understood that you could now start building computers and you didn't have to do everything yourself. And that was an amazing moment. There's something that's really important though, when you talked about competitors and understanding things about if I'm involved in creating the platform, it's enormous value that's created. How do I capture it? And one of the things that we can see in the history of this industry is that in order to do that, you have to understand what's going on at a depth that will really allow you to make good decisions. Like, I'll just give you two examples. At IBM, one was that IBM owned 30% of Intel at one time. And it's because Intel was having trouble and was under a lot of pressure, switching from being a memory company to being a processor company. IBM was using Intel's processors. So right away, you are now deep into the platform, the ecosystem, because there are companies now making processors that only IBM used to make. And now IBM stepped in because they were using Intel's processors and they invested in and owned 30% of Intel. They also, at about the same time, decided, and this is when they decided to go into a small computer. They had a personal computer. They contracted with Microsoft to build the operating system, right? But they didn't, which they could have easily done because Microsoft was a tiny company. They did not put in the contract who owns the operating system. And IBM could have easily owned the operating system, easily. And of course, those two things, the processor and the operating system, became the only sources of profit in that ecosystem that evolved over time. The only people who made a lot of money were the people who owned the processors and the operating system, until, of course, other people figured out how to do the processors. And other people figured out how to generate operating systems, right? Apple being one. So it's that the two of us have a colleague at HBS who's one of my mentors. His name's Bob Hayes. And Bob once wrote a paper, it was a case, I think, about the Swiss watch industry. And it covers like several hundred years. And he said, and he taught me this, he said, just remember, the game is never incontestably won. It's never incontestably won. There's always people who will come in. So it looks like at certain points in time, it looks like this company just has, like IBM, has a total lock, which it did. But it only lasted, look at your diagram, it only lasted for a few years because, once the technology got, now they could have, if they'd understood the platform, understood modularity, they could have figured out where's the real value that's going to be really, really hard to copy, and then owned it, right? But they didn't do that.
I find that fascinating where there's many case studies like that where they had all the ingredients, but they didn't have the lens. And for me, the book is a lens. It's a new lens to look at things. And that's why I said about that intro. If you're an investor or you're a startup founder, you can start to see things differently. And particularly at this moment in time, Carliss, maybe you'll say a word on this moment in time. I mentioned that the book's of its time, and it's, for me, what AI seems to do is modularize. It explodes things into pieces. And then if you know what the Lego bricks are and you can reconstruct them, you can create something totally different and totally new value.
I'm glad you brought up AI. It's something that is quite puzzling, because in the large language models themselves, one of the things in early days with Kim, I kept saying, how do we know it's modular? How do everybody talks about modularity. Sun Microsystems was our first case. How do you know? And the thinking was very fuzzy at the time. You kind of knew because there were little boxes and you could hook stuff together. But we came across a technology called design structure matrices, which actually require you to identify the tasks being done by people or machines and the transfers of material, energy, and information between those tasks that allow the task to be done in the right order. And I was just entranced. I'm still on a campaign. They were called DSMs. I call them TSMs now. But I'm on a campaign to get people to look at the bloody TSMs of their processes. Chip said, "That's the geekiest thing I've ever seen." And I said, "Kim, you don't understand. It unambiguously tells you if you have a modular system, you don't have to believe the necromancers, the wizards saying, 'Oh yeah, it's modular. We use modularity,' because the little transfer dots will tell you." And it makes the architecture of what's going on visible and understandable. And Kim's first paper on innovation was with Rebecca Henderson, and it was about architectural innovation and the failure of established firms. It's a very, very famous, very influential paper. And what it boils down to, and he used TSMs, they had a wonderful case study of, I think, photolithography. When you have architectural innovation, and this speaks to evolution in the computer and other industries, you're changing the configuration of the tasks and transfers inside the module. And companies often can't cross that chasm. They can't go from one kind of classic many times because they don't know what's really going on inside their architecture. And so when it comes time to make a change, they have no insight into the new thing. A good example is Amazon. Before Amazon, there was Sears, there was Walmart, and before Walmart, there was Sears. Sears couldn't turn into Walmart, and Walmart couldn't turn into Amazon. Because if you think about it, what Amazon did was it had a module that sold things, and it replaced stores with a website. And then it had a module that fulfilled things, that was logistics. And what Bezos did within a year of founding Amazon is he hired a bunch of the second from the top guys from Walmart and brought them to Amazon to set up a fulfillment process. And the architecture of the fulfillment process was a standard logistics. I mean, they are very admirable systems, but it was something that was well understood in that Sears Walmart line. But going from stores to a website, how would you do that? If you know, if particularly if you have an embedded base of managers and trained employees and inventory processes and customers who love nothing more than a bookstore. It's like an impossible dream. And that was what Kim and Rebecca pointed out in, as I said, his not his first paper, but his first paper on innovation.
Can I comment?
Yeah, it's your.
Carliss is these little off X's in a design structure matrix indicate a point of interaction where you can't do this until you do this, or this needs to be connected to this in some way, either information or material or whatever. But underneath that, in an order, are people. And sometimes hidden rules of thumb and other things that allow that thing to function. The thing that we did was based, the case we did, and that it was Rebecca Henderson's thesis, which is a remarkable thesis in and of itself, but it was organizations that were small. These were organized, just had maybe 20 engineers. They weren't huge organizations, the photolithography industry. When I talk about organization, I'm talking about those that were in the photolithography business, because some of them were divisions of big companies. But even within a small group, this process works, where a change in the architecture becomes very difficult to transition because of the organizational communication and patterns of work and design rules that had been in place before. But I want to comment on Walmart and Amazon because it's a really great example, which is Amazon was introduced in about 94. Okay. So we're 31 years since then. Today, Walmart competes really successfully with Amazon in online delivery and running a website and so forth. But Walmart lived to make it because they had this huge base business, right? And it took a long time for the customers to kind of figure out, I can get stuff from Walmart. It took a while. And even today, online retail is not a huge factor in the retail industry. It's like 20%, something like that. People like to go to stores. They like to shop, right? So Walmart had enough time and enough stickiness in the customers that they could figure out. And it took them a while. I wrote a case about a young man who, his name's Sam Bernards. He went after he was a undergraduate major in computer. I guess it was in electrical engineering. Anyway, he did an MBA. He went to Walmart. They hired him to help him figure out how to go online. This would have been 20 years ago. Okay. And maybe less, maybe 15. Anyway, but he got them online. He built a team, about 80 people. They built a website. They invented how to take Walmart. Walmart knew a lot about logistics, how to do that, build an operation that could be fulfillment. And then it became like a $300 million business, which was tiny in Walmart. Walmart had the time and the resources to live while they figured out how to make transition. The guys in photolithography, the incumbents who faced an architectural change, and there were about, Rebecca documented, there were about 6 of them that she documented because they happen every couple of years. The incumbents invariably didn't just have trouble transitioning, they died. Because the customers could switch immediately to the new technology. They saw it was better, was faster, it was cheaper, had higher quality, could do finer line widths. And the old stuff, the guys just had a hard time. And once they had a hard time, they were dead. So the dynamics of the industry also depend on the customers and what's going on in the customers' processes. And I wrote another paper about that. And the customers, sometimes customers get stuck. Like the people who like to go to retail stores. They like to go to retail stores. It's not just the stuff they want, but they want the experience of choosing and walking around and doing stuff. I'm married to a person that loves to do that. Me, I like guy shopping, which is I need X. I go into the store, I get X, and I come out. So why should I just go online? I go, X, send me X, and they send it to me tomorrow. I say, great. But I have a spouse who loves to shop. In fact, I'll tell you a funny story. You can probably edit this out, but it's a funny story. When my twins, I have turned, let's see, how old were they? I think they were about 16. When they turned 16, I took them with Sue, my wife, to New York City for a Broadway show and shopping. So we got up and went shopping, and the first place was the Gap. It's this huge, beautiful store in New York, and they had a whole lounge area for guys. So I sat in the lounge area for guys, and my daughters and my wife went shopping, and they weren't gone for like a half hour. They came back with nothing. I said, "What happened?" And they said, "There are no bargains in this store." And they taught me that for them, shopping was like hunting. And it didn't make any sense to them to pay full price for anything. So they were after bargains. And we spent a whole day walking up and down stores in New York, and they never bought a thing till we got to Chinatown. And in Chinatown, there were all sorts of bargains. And, and so if you have customers that are so wedded to shopping as a thing, you can live and survive because it takes a long time for that to happen. Customers who are really focused on speed and line width and, it takes like 30 seconds for them to switch because the equipment works the same way. It just works differently. And they figure it out. It's easy to do. And the incumbent is dead. So you have to understand the dynamics of the technology. You have to understand what modularity really allows you to do. You have to understand your customers and their processes and how it works in order to figure out where's the value being created, how does it work, and so forth. And, a lot of the book grew out of our understanding of real options, right? That all of a sudden modularity creates real options. And then we figured out, people can design stuff in such a way so as to create different kinds of modularity, different kinds of stuff that they can use. And if you understand that, the value of that, so you have a certain amount of value that's just modular, like making something modular has a certain kind of value. But if you figure out how to do the operator thing, the value just goes through the roof. And you claim it or not, or capture it or not, someone's going to capture it and figure out how to turn it into a real business. And that's where Clay Clay's work was really about how incumbent firms have a hard time reallocating resources into the new stuff, because the new stuff in his disruption world is sort of not as good as the old stuff, right? A lot of what we see in modularity and it's working out is different. In that case, you have incumbent firms that are big enough and see clearly the threat. And they do allocate the resources. They do put energy and work into creating the new stuff. And they actually create the new stuff, but it doesn't work as well. They have a hard time making it work as well because they don't understand all the nuances and all the, as Carliss said, all the off diagonal little connections that are in the new technology because they don't have experience with it. So GM has a hard time making small cars. Takes them years to make a really good small car. They eventually do, so they survived. But it took them probably 20 years before they made a really good small car. Took Xerox, they made small pocket copiers, but they never successfully transitioned out in that world because they were so encumbered by the way they were organized and stuff. It was really hard for them to. And there are zillions of other examples like that where people actually do try to make it. This happened in photolithography. All the incumbents made the new equipment. They all made the new stuff because it wasn't that complicated. It was just, we got to figure out how to make this work a little bit differently. And they all did it, but it didn't work very well because they didn't understand all the nuances. And it was the nuances that made a difference. And their customers could move. There was nothing, they weren't locked in. There was nothing that kept the customers from moving. So whether you exploit the value or not depends on how well you understand it, that technical dynamic as well as what's happening to your customers.
So let me bring this to AI. And the other amazing thing in the Henderson-Clark paper is a sentence at the beginning of the conclusion that says, organizations mirror the structure of their task, more or less that, which is saying, it's so if you skip a task or you skip a transfer, that's often fatal to the outcome. But no one had ever said it before. And in order to mirror, you have to understand the process at a very micro level. That's why the DSMs were so fabulous, because they pointed out at that time in management theory and practice, top managers had abstracted away from actual processes. I'm going to be whatever disrespectful. So strategy came along and said, the unit of analysis is something akin to a company in an army. The top brass doesn't have to know what's going on with the sergeants. The sergeants do that. And so we think like generals, and everybody wants to be a general, and especially Harvard MBAs want to be officers and then generals and then commanders in chief. Well, if it's the fine structure that is hard to see, that is the true basis of performance, then you want to have an understanding of fine structure. Today, we're hearing about this in AI. The buzzword for the DSM right now is workflows. Companies, in order to use AI effectively, are having to map their workflows, which they didn't do before. But now they have to, because the AIs need help understanding workflows. But there's also differentiation across the steps in the AI process. So what gets all the attention are the LLMs, the frontier models, I think they sometimes call them. And they are trained inductively based on, everything ever written by man or woman or child. But nobody sees what goes on inside the frontier model to put the sentences together. That's very much a black box. Anthropic has tried one thing where they can isolate certain words to certain sections of the LLM, like people can see what parts of your brain are activated by certain triggers, thoughts. But nobody knows how the LLMs are truly wired because they don't learn that way. Now we have agents. And with agents, to access the power of agents, you have to think of the agents as modules, and you hook them together in an architecture to do different things. My daughter treats her life this way. She has her recipe agent. She has a whole bunch of agents doing different things in her life. And then you have to be more formal about how the agents interact. And I think, now I've not been part of any AI deployment at an actual company, but I think where they're struggling is in the fact that they have never had cause to actually map the tasks and transfers that go on inside these units that are called divisions, departments, offices, teams, because, it hasn't paid or they don't think it pays. But now because the AI demands it, they're all struggling to map their workflows.
This is a perfect segue for a great story that you tell, and where there's a real threat with AI of the black box. And I'll give you, because you told the story about the supermarket, Kim. I had one of these recently where about a decade or more ago, when I moved into the house I'm now living in, actually it's going on 13 years, I planted a hedgerow around the border of my just garden. And there used to be a road that ran through it. So a certain part of the hedge has literally got compacted soil underneath. And I took out 3 big massive bins worth of soil. I changed that soil. But this piece just of the hedge struggled to grow. But we had a landscaper who comes in and cuts all the hedges in the gardens in where I live. And he knew, I had told him, was like, okay, this, just to understand here, this runs under here. This piece is struggling to grow. We need to have patience with it. I'm feeding it. So he knew about it. Then the management company who looks after our grounds changed the landscaper. The new landscaper comes in. I come home one day. It was only recently, butchered my entire fence, my hedge, like years of growth gone. And he took it down to the lowest common denominator and thought he was doing me a favor because it looked neat. And I thought about your study of the automobile industry and how institutional knowledge can be lost and has dramatic effects, way worse than my hedge, as you showed with the automobile and the hood and the oscillation and the vibrations of the hood. I'd love you to tell this story because it absolutely exemplifies what Carliss was saying about the threat of the black box and the threat of losing knowledge and actually know-how.
So this was a real problem for the automobile companies in the U.S. who were moving from big cars to small cars. And the hood of the vehicle is a good example of the problems they face, right? Because the hood covers the engine compartment. And in a large vehicle, there's a lot of room in the engine compartment. And so they learned over years, and it really was tacit knowledge. It wasn't formally, written down anywhere. It wasn't part of a modularization. It was just guys figured out how to do it. And you figured out where to put stuff and what the dynamics of the vehicle were. It's noise, vibration, harshness is the measure they use. And they had these rules about how you do this. When you do a small car, the hood is much smaller, the engine compartment is much smaller, and there's not much room in there. And so you have to figure out how to, quote, package the engine compartment so that the vibration of the vehicle and the acoustics especially work in such a way that it's a pleasant experience for people who drive, right? So the first small cars they introduced were subject to a lot of vibration that they were not familiar with. And so literally when they first took these cars out on to test them, the hoods would vibrate. When they literally would roll like a wave, because there literally were waves waving through the steel. The steel is very thin in a hood. If you ever go look at it, it's very thin, and it was waving because of the acoustics and the vibration that they created. And it was very difficult for them to figure out how to make a small engine compartment and a hood that didn't vibrate. They had to kind of create a whole new set of, quote, design rules that how you put in it, because essentially the engine compartment was very modular, right? It's got certain things that have to be in there, and where you put them and how they hook together is, these are all modules and so forth. And it goes down to things like, how you build an engine and what the engine looks like, and how you build, the battery. Where do you put the battery? And, you've got a coolant system, and where do you put that? And how do you put where you put the pipes and the tubes, all that stuff. Anyway, the worst example of the problems that this created was a vehicle called the Vega, and it was created by Chevrolet. And I happen to own one, unfortunately. But when the Vega was first put on the test track to drive around, it literally fell apart, which meant that the vibration in the vehicle was so severe that it actually tore some of the fasteners and the bolts and stuff. They sheared off, and the whole thing, the thing fell apart on the test track.
Oh my.
And they realized they had a whole different animal that they were dealing with. But it was very hard. It was really, really hard to figure out how to build a really, really good small car. And, not just wouldn't fall apart, but would be really smooth and, low cost and no harshness. And when you drive it and, all that stuff, it was and it's exactly what we've been talking about. They got hit by the little off diagonal X's that they didn't even know existed, and it just took them a long, long time. And they tried, and they got better, and they got better and better. And today, the American companies have actually abandoned small cars pretty much because they don't make money. And in fact, I think Ford doesn't make sedans anymore at all. They just make SUVs and trucks and so forth. So fascinating.
There's a really important lesson in there that you could easily miss. So many people in organizations, people who have great ideas, may articulate those ideas and they don't go anywhere. And they get very, very frustrated. You give an example of a kid called Jake, and my son's name's Jake, so it resonated with me. But you have an idea, let's go with the mug or the hood. And I'm like going, why don't we use a lighter material? Like goes and spends ages trying to design this, maybe create a prototype, present it to the company, and it totally bombs. But as you say, and the huge thesis in the book is, you can't just change one module. It affects the entire thing. And I think that I'd love you to share that as a concept that our audience can really grasp, because You can see where frustration comes from if you don't understand how the modules stick together.
Well, the optionality comes from the fact that there's some things you don't have to track. And that's the trick of reducing the interactions from the mess that is the natural state of a complex process to a bunch of pinch points coordinated by design rules and by system integration. That's a big learning process. And to do it consciously, truly, it was an invention, not an evolution. It was not where the organizations naturally wanted to go. Divisional corporations are the natural evolution out of smaller corporations. So you hook them together, you create a staff that understands or is socialized to provide the glue, and you have kind of a dirty modular structure with blocks and then connections between the blocks. And a lot of the connections are provided by the staff. But when you have that mindset, there are places you can't go. Like GE tried to do computers. And GE was a behemoth in the 50s and 60s. I mean, they did everything. General Electric, Thomas Edison's company, anything that used electricity that was in the purview of General Electric. And they tried to do computers, and it never worked for them because it's not very natural for a big company to be modular. The danger is that the modules fly off, and you need to think very hard about where the points of control are so that the value doesn't all flow to the modules. They have to remain beholden to the platform in some way. But if you start out as a line staff company and you want to become modular, there's nothing in your DNA, in your corporate DNA, that would suggest to you what IBM did. I mean, it took IBM, had to set up many new centers and be very strict to prevent the modules from depending on one another. And they were almost the entire rest of the industry was de novo computers. They didn't have a past like IBM. And so just as with Amazon and online shopping, they weren't mired or constrained by a past set of practices. If you look at, all the generations after IBM, Kim was mentioning Intel, Microsoft. I mean, these are modular native companies that started small and got big. So that there really is history constrains you. Your history constrains you a lot. Just as I'm hopeless at AI. I'm not AI native. I'm trying. I really am. But I'm not AI native. And I just wanted to put in one thing about design rules before there were instructions before there were design rules were in the form of switches in a large array of circuits. The array was as big as a room. And you had women, usually young women, who went and flipped the switches to make the instructions, to make the circuitry correct. And there came to be a term, it's called a kilogirl. And it was what you needed to do 1,000 instructions per hour, a kilogirl. Only I think it was a day. But it became a standard. A standard was a kilogirl. And so that standard went away, but it was there for a while. And those were the days when a big company would have rooms full of women on calculators putting in the transactions for the company. The processing speed of one of those women would be the measure of a kilogirl.
So let me just say a word about what Carliss has introduced there. Not about the kilogirls, but about the difficulty of as you said, of a module coming into being that it actually might obey the design rules, but it also has other interactions that have not been anticipated. Right? So imagine the following. Imagine an organization that is consciously modular itself. This is another thing that we wrote a paper in 1997 or published in 1997 in Harvard Business Review. And if you go back and read that paper, the last 2 paragraphs, I think, lay out possibility. This is apropos of what Carliss called the mirror hypothesis. We set out and we said, it's possible that modularity could become a feature of the organization itself. As the organization could be consciously, explicitly modular. So imagine a situation where you have that. And there are a couple of things that have to be in place for modularity to work at all. And they are part of, design rules are part of it, but you also have to have an architecture which figures out, well, what are the modules? And then thirdly, you have to have a way to test a module that it will actually function well in the system so you don't have to design and put in operation the whole system. You can test the module independently. So imagine you've got that and you've decided, well, we're going to try to create an organization that's sort of modular. And so we've written about this in this book we published a couple of years ago. And what we decided as we worked on that was that, and even subsequent work that we've done, is that it turns out that leadership is actually the operating system of the organization. And it's the way decisions get made. It's the way information moves around. It's the way people interact with one another and so forth. And if you design a company, you could design a company that is actually modular itself around teams. And if you create a setup where the leadership becomes the operating system for a modular system, okay, so it's got to have that character, then you can actually do it. And there are some examples. So one example you may be familiar with is Hire.
Okay.
It's a appliance company. I don't know if you're familiar with what has happened in Hire in the last 10 years or so. But Hire went from having a classic, fully integrated organization with 12 different layers of management. It was like at the time, it's probably like a $30 billion global organization headquartered in China, but operating all over the world. Hire, by the way, apropos of what Carliss said, bought GE appliances.
Yeah.
But a few years ago, Hire decided that they were in a death spiral. they couldn't move fast enough with their big clunky organization to respond to technology changes and competitive moves and global dynamics. They needed a much, much different organization. And bless their hearts, they completely created a complete different organization. It took them a while to do it. And what they did is they created at the bottom their modules, which are teams. And in Hire today, there are 4,000 of them. And above them is one layer, and it's called ecosystems, right? So the teams are all in different things like, one team is actually a factory. So the GE appliance factory in Kentucky in Louisville is a team. Anyway, they got all these teams, and they have designed it so that the staff is where the resources are, but the action is all in the teams, and the senior executives no longer issue instructions or commands. It doesn't work that way. These senior executives now are investors and architects. That's what they do. They architect and they invest. And then the middle layer, there's only 3 layers. The middle layer are people who watch over the ecosystems. And then you have an ecosystem leader. And then you've got an ecosystem leaders basically it's a very modular structure, meaning that the teams can kind of come up with whatever they want to. They can get resources internally. They have to contract with the staff for resources, or they can go outside if it's a better deal. And so they become very entrepreneurial. But in order to function that way, there has to be information about the architecture. And the architecture for that kind of organization includes what's our strategy? What are our values? What are the principles that we want our company to operate under? What are our objectives specifically? And everybody, all those 4,000 teams, and the teams are like 10 to 15 people. So you've got thousands of people, and, they have a big organization. Say they're I think they're all $70 billion in revenue. Anyway, here's an example of a team. There was a team whose responsibility was rural washing machines, or washing machines sold in rural areas of China. Okay, so it's in China, and they're selling washing machines to rural customers. That's the team, right? And there's like 10 or 15. They design the products. They figure out where they're going to be made. They contract with them, the operations about how to distribute it, market. So they build all that, right? They're the team. They discovered something. And that is that their customers were using washing machines to wash vegetables. And they put the vegetables in the washing machine. They wouldn't put soap in. They just turn it on and go through the wash cycle. And it turned out it worked really well, right? So the guys thought, well, why don't we do that and make that a feature of the machine? So we can do it a whole lot better, because we can create better baskets. We can create an actual cycle that does that. And they designed it. They worked with engineering to get it done. They figured out how to make it, get the products made. And it became I think it was like $100 million business, because it was a really valuable thing for their customers. The old Hire would never have figured that out. They couldn't possibly have figured it out. So the idea is you put this team really close to customers. You give them flexibility, but they have a framework they operate under, which is, what's our strategy? What are our values? What principles do we use? What are our objectives? So that kind of very visible information goes way down. So somebody operating in whatever country knows as much about the strategy of Hire as the CEO. And then they can make good decisions, and the decisions work together, and they figure out how to make, the staff is a support group, they don't tell people what to do. So it's possible to do this. It's possible to create, and they're coming up with modules and these teams that nobody ever thought of before, right? But because the organization is explicitly modular, they anticipate that that will happen. It will happen. And it's a good thing because now we figure out, oh, how do we make this work? And that says, okay, and Carliss she loves DSMs. What are the X's, right?
Yeah.
How's this going to work? What are the X's? How do we build it? How do we connect it? And then work with the staff and, but it's happening 4,000 teams across the whole world. Hire has grown much faster. It's much more nimble. It's much lower cost than ever before. And it's like a dynamo because they've unleashed the power of modularity in the organization.
Did you write about that in Leading Through? That's where I read it from.
Yeah, I think we had one little example in there. We certainly have done it. We certainly have done it in the work we've done subsequently.
Yeah, it explains to me how you understand how you've got to your level of thinking now. And like Carla said earlier on, IBM was the environment. And to me, it's like where you're working now with the Leading Through Institute. It's like leadership is the environment to enable this now. It's the same thing. And if you understand the lens of modularity, you can architect the organization to be modular. We need to finish up now, but the thing I really got out of the book was this as well. I mean, so many aha moments, and I love going back and really getting my hands dirty with this content. But 1968, Conway's law that the product is imprinted in the organization structure, and then your paper came with Rebecca in 1990. That actually, that's the mirror. It works both ways. It actually gets imprinted back into the product as well. And then both you and Carliss Clark, Kim, your content together lets you understand it. And then you go, well, actually, we can do something about it. And that was kind of one of the many, many moments of joy of understanding this content that came to me as well. So it's a brilliant book. And you know what? We didn't even get near any of the things like substitution and all the different kind of ideas that are splitting that are in the book, all these great concepts. Maybe we'll do a part 2 and share those the 6 real key ideas that you can actually architect a modular organization if you understand these things. Kim, I'll come to you first and maybe share your final thoughts, but also the work you're doing today and where people can find you.
Well, first of all, thank you for putting us together. Carliss and I started working together about 1985 or 6, I think, somewhere in there.
Yeah.
And we worked together for, 20 years.
Yeah.
And this is exactly what it was like. Back and forth, we had a lot of fun together. So thank you for putting us together. I will just say that it's a little bit like the little boy with a hammer. Everything looks like a nail. And once you understand modularity, it's everywhere. And it's really, really powerful. And Carliss's explication of AI agents and workflows and stuff is really a wonderful example of how this concept can help you understand things that otherwise you have no idea what's going on. So it's a really powerful idea, and people have understood that now, and it's a commonplace, but it was a real joy to work on this stuff together and to discover these things, and to see them in action is really wonderful. And I think what we're doing now, we published this book a couple of years ago called Leading Through, Activating the Soul, Heart, Mind of Leadership. And what we've learned since then is to think of leadership as the operating system of the organization, analogous to an operating system in a computer, where leadership really does carry that weight in the organization. And every organization, in every organization, leadership is the operating system. And some operating systems work really well and some are horrible. and they chew people up. They fail their moral responsibility. They actually hamper potential in the organization and so forth. Others are much more powerful because they become, the closer they get to becoming truly modular. So that's why we call it the modular leadership system, is that leadership is not just, it is definitely personal. It's really important part of it, but it's also organizational. So that's an important thing we're working on. We've created this thing called the Leading Through Institute. And we've now come to understand a deeper thing, which is that the leadership, the way we defined it, coupled with AI, because we've now created a learning platform we call Permeos, which allows people to learn the principles of leadership and the operating system deep. So it's not just what they know, they understand its value, they feel it, they do things, they become different people. And in that context, the combination of modularity coupled with this AI system means that what you create is the infrastructure for any business system that you want to implement in order to operate. And it becomes the structure that you use. It's sort of this underlying structure, but it's inherently modular. So you design it that way. You design the AI platform that way. So the platform itself is modular. And it's just like incredibly powerful.
Unbelievably powerful. And I'll link to your website as well, Kim. It's leadingthrough.co. But I'll link to that, and I'll link to the episode we recorded with your brilliant daughter and your son, John, and Aaron as well. I'll share that in the show notes as well. But Carliss, it's coming to you. I learned so much from you. I wanted to ask you, because on your second volume, Design Rules Part 2, the cover has a signification, and I wondered what it was.
Yes. Let me.
Kim, I got a copy there, Carliss. Look.
Oh, okay.
Kim has it there, Carliss.
Yes. So that is a picture I took of the inside of St. Mark's in Venice. I own the copyright to the picture. There is a famous essay by Stephen Jay Gould and Richard Lewontin called The Spandrels of San Marco. And the spandrels are the arch goes up, and then the space between the bones of the arch, those are the spandrels. So you can see a couple of spandrels in this picture in the middle. Gould and Lewontin's argument was one I found compelling. It was that they were undergoing some kind of debate with their colleagues about evolution. And they said, some things exist because the physics requires it. So the spandrels exist because if you want an arch of that kind, you need that space. You need those quasi-triangular areas. It was not that somebody said, I want to create art in quasi-triangular areas. Although all the spandrels are filled in with beautiful art, it's that the architecture demanded that the space be there, and then creative people made use of that space. And people are more respectful of technology now. Kim was a huge influence on management and on all of us about the importance of technology. But there's a whole school of scholars that don't think technology matters. You can have anything you want in an organization. It's all socially constructed anyway. And I always felt, that since Kim, recruited me soon after I got tenure, I was in the finance group and I didn't have any idea what I was going to do next. And he said, come and learn about technology. Not about production, but about technology. And it was to say it was eye-opening. It was an amazing world unfolded. But one of the things that became a conviction was that the world will be what it is, whether you like it that way or not. And you just can't argue with physics or chemistry or bio, you just can't. And so that made me feel that technology is the foundation of management, because that's where the rubber meets the road, and you just got to deal with it. You can't wave your hand and say, oh, I'd like an organization to be this way, without comprehending that there's some rules. Anyway, so the book cover, I was looking for a cover, and I said, there's nothing in the book that even mentions the Spandrels of San Marco. So this is the backstory to that cover, which I like very much.
Beautiful. Well, you two are the spandrels of
Right.
of this content, and it's been an absolute pleasure having you on the show. I'll link also, Carliss, to where people can buy the book as well, and part one as well of the book.
The book is available open access.
See this, but the tagline is the key: how technology shapes organizations.
Yeah, and that's it's not how organizations shape technology. It's about you deal with the technology and your organization follows, which is probably not exactly well. So Kim is the leadership expert. I've never purported to be an expert, although I have to say Kim's leadership is a lesson in itself, and what he did at the school was amazing. What he's doing with his institute is amazing. Taught me a whole lot. Taught me everything I know, but I was never my ambition to be a leader. I never thought it was something I could aspire to. So anyway, that's neither here nor there.
This book nails this topic. It absolutely nails it. It's really, really hard to argue with this book. And that has a profound influence, because so much of today's society is based on something completely different, which is there are no spandrels. That is, that everything is, there's no such thing as truth. You create your own. There are no absolute laws. There's nothing that, you just kind of create your own. And everything's relative. And that turns out not to be true.
Amen. Guys, it's been a huge privilege. And I have to say to you, Carliss, you said earlier on that you didn't know anything about AI. Or now you're saying about leadership as well. You sound a little bit like IBM when they had Intel in their grasp. You have the ingredients and you've proven it. It's been an absolute pleasure. Authors of Design Rules, Kim Clark and Carliss Baldwin, thank you for joining us.
Thank you.
Thank you.